Hello everyone. So today we are going to continue again that same topic solution. So in that one we were discussing about factors affecting solubility. So today we are going to take a next part of that one. It is the third factor. It is affecting solubility is that pressure. See this factor pressure will not affect. So first I'll write that one. Pressure will not affect solubility of solid in liquid. Solid in liquid, if I am dissolving, then pressure is not a important factor which will affect the solubility. So that's why, so for this kind of solution it is not applicable. It is only applicable. So pressure is important when gas is present in liquid, means gas is dissolving in liquid. At that condition pressure is a very important role. So now we are having solution that is present oxygen or any gas is present in the liquid. At that condition only pressure will be come into the picture. Now let us start with this pressure. So let me take one example and will explain this one. That is Henry's law. We are going to start here. See, if pressure increases, then solubility of gas in liquid will increase. See, for example, I am taking one example here, that is let me take oxygen in water. Okay, so here I am having one beaker here. So here I am having two beakers. Okay, in this one I am having water is there, and upside I will take a different color, that is upside I am having oxygen gas, and some oxygen gas also there inside the water. Okay, so now I am having one piston over here. I close with the piston. So this is a piston. So I will apply pressure, increase pressure. What will happen means, so when I apply pressure, means this one I am applying pressure downwards. So now what will happen means, water will be this much only, water will remain, the quantity of water will be same, but what will happen means the amount of oxygen gas in water will increase because of more pressure, because of pressure I applied, because of the pressure I applied on the gas. Okay, so this is the effect of pressure. So now this is explained by one scientist that is only called who is only called as Henry. So Henry's law, what Henry's law says that, so according to him, at a constant of temperature, at a particular temperature, solubility of gas in liquid is directly proportional to the particular temperature. Solubility of gas in liquid is directly proportional to the pressure or partial pressure of a gas. Partial pressure of gas. So this is according to Henry's law. What is saying that, see, same example I'll take. So here I am having water, upside I am having that is oxygen gas. So now I am applying pressure, means if I am applying pressure externally, so this will create some pressure on oxygen gas. So now oxygen gas also will apply pressure on the water only, no? So that's why, so if the partial pressure of oxygen gas is increasing, then the solubility of oxygen gas in liquid also increases, no? So that's why that is only saying at a particular temperature solubility of gas in liquid is directly proportional to what? Directly proportional to the pressure or partial pressure of gas. If partial pressure of gas is increasing, then of course solubility will also increases. So to create some more thing, and then one more scientist came, that is Dalton's came and he also said that yes, of course I agree with the Henry's law. So Dalton's made some changes regarding in this law. See, before into the Dalton's law and combined law, so we will take this example. See here, in this container, suppose I am having water, same thing, water is there, and oxygen gas also is there here. So upside oxygen gas is there, down also some in the solution also oxygen gas is there. Now if I am increasing the pressure, what will happen? Oxygen gas will dissolve more in water. Oxygen dissolve in water. If oxygen gas is dissolving in water, quantity of oxygen is increasing, quantity of O2 increases. Quantity of O2 is increasing means what? Quantity of O2 is increasing means mole fraction of O2 increases now. Mole fraction of O2 is also increases now. So that is only called as Dalton's law or Henry's law. So what he says, that means so that is partial pressure of gas is directly proportional to mole fraction of gas in solution. So if partial pressure of gas is there, if partial pressure of gas is more, then O2 will dissolve in water will be more, then quantity of O2 will be more. If quantity of water will be oxygen will be more means what? Mole fraction of oxygen is also more now. So that's why partial pressure of a particular gas is directly proportional to its mole fraction in solution. This is only called as Dalton's law at the end. So we will get this Henry's law, that is what is Henry's law says that. So we will combinedly write Henry's law and Dalton's law, both will combinedly write as like this: partial pressure of gas is directly proportional to mole fraction of gas in solution. So to remove this proportionality constant, that is partial pressure of gas is equals to one constant, that is Henry's constant Kh is equal into mole fraction of gas. So this is only called as Henry's law. So now we will talk about the importance of Kh here. What is the importance of Kh? So importance of Kh is that, see what is the relation between Kh and mole fraction of gas. If I can write like this also, no, P partial pressure of gas into 1 by Kh is equals to mole fraction of gas. So what is the relation between this Henry's constant and mole fraction? If Kh increases, mole fraction of gas decreases. If mole fraction of gas is decreasing means what? It is indirectly saying that solubility of gas also decreases only now. So that's why we can say if Kh value is more, then solubility of gas will be less only, decreases. If Kh is more, then solubility of gas will be decreases. So this is a very important concept about Kh, Henry's constant. So remember this one, try to remember this one, okay, very very important. Okay, so now this can be also represented with the graph. So they given one graph like this, there is a mole fraction of gas and partial pressure of gas. So the graph will come like this. Okay, see what it is saying, graph, it is linear graph, it is there. So as mole fraction or as partial pressure, see this partial pressure is increasing at this point, at this point, at this point, partial pressure is increasing, solubility also increases now. See, this is a mole fraction, solubility is also increasing at this point, correct now. So this is only the graph. Okay, so what is the slope here? Slope is what? Slope is equals to Henry's constant only, that is Henry's constant, that is Kh, that is 1 by Kh. Sorry. Slope is 1 by Kh. Okay, so this is the slope of this graph also. So this is a relation between partial pressure and mole fraction of gas. Okay, and one more thing important, note that, see this Henry's law is applicable for less soluble gases. Less soluble gases means what? like we can take oxygen is also less soluble, nitrogen gas, hydrogen gas, helium gas, neon gas, and xenon, radon will not take, and argon. So these kind of gas only it is applicable. It is not applicable for Henry's law, not applicable for highly soluble gases, like what? Like ammonia is highly soluble in water, and one more gas is, that is HCl, is also highly soluble in water. So why these are not applicable? Why for this gas Henry's law is not applicable means, see here, if I am taking HCl and NH3, if I am adding into water, HCl if I am adding into water, it will form H3O plus Cl minus. Ammonia is also I am having, it is NH4 plus OH minus. Ions it is going to form now. Ions if it is going to form means, so this law is not going to apply. And one more point is that Henry's law is applicable at lower pressure and higher temperature. In this condition only it is applicable. Okay, so this is a Henry's law. And some more points we have regarding this Henry's law, that is see what, like I will relate with the KH relation between KH, temperature, and solubility of gas. Okay, if temperature increases, what will happen? KH value increases, solubility of gas decreases. Yes, of course. See, if I am increasing temperature, solubility of gas will increase. If I am increasing KH value also, solubility of gas will increase. Sorry, solubility of gas will decreases, not increases, sorry, it is decreases. So that's why if temperature increases, KH value also increases, solubility of gas in liquid decreases. Remember, very important topic. Okay, very important point it is. Okay, so this is about Henry's law. So I think I covered most of the points in Henry's law. So next, coming to the applications of Henry's law, where this is applied, application of Henry's law. So applications of Henry's law, where it is applied means, in first condition or first application is that, so like we are going to drink this is soda water, no, soda water or carbonated water, or like cool drinks will be there, no, Sprite, 7up, these all will going to drink, no. So in that one, if I open the bottle, suddenly some bubbles will come out or some gas will come out. That gas is what? That is carbon dioxide gas. Generally carbon dioxide gas is less soluble in water, but what they will do means, they will give high pressure. At high pressure CO2 is dissolved in more quantity. So CO2 is dissolved in more quantity by giving high pressure in the cool drink bottles. So that's why when I open the bottle, so because of pressure release or pressure will decrease, so that's why that CO2 gas, whatever it is dissolved in that liquid or in that cool drink, it will come out. That is one application. It is the Henry's law application. There also it is utilizing. Second case is see scuba divers. See that scuba divers will be there. No, means scuba divers means who will explore the sea. Those are called as scuba divers. Okay, so scuba divers will face one disease called as Bent's disease. What is it? Bent's disease. So scuba divers will face some disease that is called as a Bent's disease. What it is? See, so when they will go inside into, so this is a sea. Okay, listen carefully. Now scuba diver is taking oxygen cylinder and going into the sea downside. So when he is here, so pressure will increase, yes or no, because of water present upside him, so pressure will increase. So as the pressure increases, then solubility of oxygen and N2 in the gas cylinder, what will be there? Oxygen will be there and nitrogen also will be there, na? Air they will take. So oxygen and nitrogen they will take. So oxygen, solubility of oxygen and nitrogen will increases. But one point here is that this oxygen which is going to soluble in more quantity in blood, pressure increases, solubility of O2 and N2 gas increases in blood. But this O2 will be there, no? This O2 which is dissolved in blood, it is utilized. It is utilized because of metabolism. For metabolism it is utilized, but N2 is there, no? It is not going to utilize by the human body. So that's why what will happen means, so this N2 will be dissolving more in blood. And what is the problem means, when the scuba diver will, when he will come upside again, then at this point what will happen? Pressure decreases, now pressure decreases, then N2 which is going to dissolve in, which is already dissolved in blood, it will start to come out as a bubbles. N2 bubbles will form. N2 bubbles will form means those will block that blood vessels. So because of that one only, some diseases they will face a severe pain. So that is only called as Bend's disease. So to avoid this one, what they will do means, they will take cylinders which are having around helium. They will dilute this cylinder with a helium around 11%, that is 12% of helium plus, and 56% of nitrogen plus, and remaining percentage, that is around 58, that is 32% of oxygen. So this cylinder they will carry. So this will not affect that much. This will not create the Bend's problem. So this is the second application. Third application is that now mountain climbers will be there, no? Mountain climbers. So mountain climbers, see, suppose I am having, this is a one mountain we are having here. So now you are climbing a mountain. So at this point, at this peak point, see, because here air will be there, oxygen will be there, this oxygen will be, less pressure will be there, less pressure of oxygen will be there. Because of less pressure, oxygen will not dissolve. Because of less pressure, oxygen will dissolve in blood, less. Oxygen will dissolve in blood very less amount, na? So if less amount of oxygen is available to us, then we cannot think properly. So our mind will not work properly. So we will dizziness problem will get, dizziness problem, and we can't think properly, and some headache problem will come. So these all combinedly, it is called as one disease name. These anoxia will also form. Anoxia disease also they will face, that is mountain climbers. So these three are very important applications. You remember these applications also. So this is about Henry's law. Okay, this is only Henry's law. So very important law. So this is the effect of pressure. So three effects we studied of the solubility, that is one is nature of solvent, nature of solute, and that is next temperature, and next we studied effect of pressure also. Okay, so in next class we'll continue next part of the solution. So until then, bye, thank you.